So here's an N3ZI DDS VFO mounted in a little box. We're going to do a little work on this. It used to have a TR switch and a keyer built into it, but that's been removed. So we're going to add a keying buffer to this, and what else? So set up the RIT so that when you depress the key on a boat anchor transmitter, it turns the VFO on, and in the receive mode it's going to shift the VFO like a megahertz away from the actual frequency so it doesn't interfere. That's what we're up to. But in the process of checking this out, I spotted a few things, so let me show you to them. Hang on. Okay, so this is a pretty cool kit actually, and I came real close to getting one of these, and I might sooner or later after all, because I think it'd be fun to play with. I was going to get it as a piece of test equipment, kind of use it as a signal generator, but I'm glad I didn't. There's better options. Anyway, here's the N3ZI board here and here, and the encoder mounted down here. This is an aftermarket power amplifier board for driving a boat anchor transmitter, and it's been changed. There's a resistor right here that's been changed, a resistor right here that's been changed, and one here that's been changed. These are not original values. I don't know why they were changed, but I can show you the effect. I'm pretty sure it screwed up the biasing on that power amplifier. So let me get the scope up here. Hang on. Okay, so the big issue here is on the lower frequencies. I'm on 80 meters right now. What's it say? 3556.98. And you can see, I hope, on the scope what the output is like with no load. If I put a 100k ohm resistor on it, it'll drop a couple of volts. But look what we've got here on 80 meters. Almost 60 volts peak to peak. I don't know if you can read that or not, but this is the measurement side here. And I have peak to peak voltage, max voltage, and what the equivalent RMS would be. So anyway, just about 60 volts peak to peak, but look at the bottom here, squared off, probably harmonics involved there. That looks to me like a biasing issue where it's not centered at the Q point for the amount of voltage swing that we're getting. And I have a feeling that has to do with those resistors that have been replaced. So anyway, and if I go down to 160 meters, there's 1817, and that looks pretty ugly. In fact, the frequency counter in the scope is confused. It's reading 3633. It should be reading 1817 because of this distorted waveform. But again, 50 volts peak to peak max. Now, if I go up to 40 meters, things start looking a little bit more reasonable here. We still don't have a perfect sine wave, and our voltage has dropped down now to 44 volts peak to peak. If I go 30 meters, 10.114, we're at 36 volts peak to peak. 14.172, 26 volts peak to peak. 17 meters, just a shade under 20 volts peak to peak. 15 meters is 15 volts peak to peak. 12 meters, looks like about 11 volts, and 10 meters is about 10. So anyway, I am pretty sure that power amplifier is not biased properly. But you know what? It may not really make any difference in the application. Whether the bottom half is clipped, because the frequency remains the same. It just may have some extra harmonics due to the square edges here. So something in that power amplifier, and I'm sure it's probably related to those resistor changes, has caused a somewhat distorted waveform here. Anyway, that's the N3ZI DDS VFO. I still might get one of these and play with it. It's a pretty cool kit. That aftermarket power amplifier, maybe if it was restored to its original resistor biasing values, might clean up that output a little bit. I don't know. I don't know the history. But anyway, keep on tinkering. This is kind of fun to play with, so see you guys later.